My name is Mila Atanasova. Title of the SAR study is Monitoring of the Landslide, Thracian Cliffs, based on SAR technique. The main objective of this research is monitoring past and ongoing ground instabilities based on exploiting the benefits of combining geological SAR and GNSS data. This study is providing reliable information with regard to the hazard geoprocesses taking place in the region of the landslide area, Thracian Cliffs, just before the entrance of the Thracian Cliffs Golf Club. Usually landslide bodies are formed by 3 to 4 visible linearly oriented steps and hills, landslide packages, having different heights. Most often behind them are located enclosed negative ground forms with permanent or temporary swamps. There are small and narrow sandy beaches in the area, which cannot protect the coast from sea abrasion. The landslide is active. The road to the golf club is asphalted, and in the new pavement in some places thin cracks with a size of 2 to 3 centimeters can be seen. On one side of the road the east board is clearly visible, from which a landslide package has been cut, Figura 2 and 3. The massive buildings, see Fig. 2, affected by the landslide processes are uninhabited and visibly look like abandoned ones. Geodetic geodynamic networks established for landslides monitoring consist generally of 2 types of points: reference or fixed points located on geologically stable terrain and survey points located within the landslide. In the framework of this study, a control local geodynamic network covering the landslide area located in the surroundings of Thracian Cliffs Golf Club was established. In it included 10 points, which are used to monitor deformations. Figure 5. Static mode was applied for the GNSS measurements in June 2019 and July 2020. In this research we created a time series of interferograms from Sentinel-1A/B satellites starting November 2015 and ending April 2020. Next we set the time between 2 scenes forming the interferograms to be 4 months in order to have minimum vegetation cover. Other constraint we had to cope with was to find those scenes having not very large perpendicular baseline and high modeled coherence table 1. This way we formed 6 interferometric pairs that have been used in the next steps for DinSAR processing. In Figure 6, an excerpt from the resulting NTER ferrogram, Orbit 36 ascending, overimposed the Google Earth raster is provided covering the area of Thracian Cliffs landslide zone in Figure 7. There occurred ground displacements in loss is calculated from the phase signal after unwrapping. Used was SNAFU software, color-coded, and it can be noted that over a 4-month period for 2015 to 2020 year, they vary between -5 and -10 centimeters. Only the period in the winter of 2017-2018 the values of the movements reach -20 centimeters. The final results obtained are listed in the Table 2. In it the information obtained from interferograms regarding the ground movements for period is provided. For this purpose, for every point of the geodetic network the pixel at which it corresponds is located. In the same table the number of the geodetic point and displacements loss per meter, for all periods. Conclusions. The results presented provide solid base to affirm that the interferograms produced from satellite SAR data are suitable for studying the ground displacements. For the studied period the displacements calculated are in range of few centimeters to decimeters, which is in line with the expected yearly values for researched area. This information can be considered as the only source for this site and at this moment, since large areas of the terrain is difficult to reach and impassable. Thank you.